So what we're going to be talking about today is using a TU5400 ultra-low range turbine hooked up to a controller. In this case, we have an SC200 controller right here. And setting it up in a scenario where it's used in a membrane plant. So it could be reverse osmosis, microfiltration, nanofiltration, in that type of scenario, in that type of setup. Those of you that are familiar with this know that there is somewhere along the way you have to do some form of a pressure decay test that uses gas, it uses air, and then it introduces air into the sample line, and that can cause problems inside of the turbine. So the turbine is working fine, it's working the way it should. Turbine emitters work on the principle of light scatter, so bubbles, just like particulates, will get into the turb, cause light to scatter to the detector. So it's working fine. However, it can be a little bit of a headache if you're getting bubbles in when you're really looking for particulates in your water. So what we're going to do is show you how to plumb this and set it up to minimize the bubbles. I should also say that it may not completely get rid of the bubbles. It may, but there may also be some management that has to happen on the SCADA side. So you can put in a little bit of a delay on your SCADA system. So when you're not producing water anyway and bubbles enter the turb, you're not having any problems. All right? So let me get started showing you what we have here. So this is your sample line right here. It's coming into this side of the turb. You'll notice that there is nothing in between where the sample is being drawn from and the turbine emitter itself, and that's by design. Ideally, you wouldn't have anything in between the turbine where the sample is being drawn from. The only thing you may have, if you have big pressure and flow fluctuations in your plant, would be some sort of pressure regulator, just to maintain the proper pressure going into the turbine emitter, so it doesn't completely lose pressure, it doesn't go over pressure. So it goes in here, then it comes out the top, and so you'll notice as you follow this down, this black piece of tubing right here, this is 1/4 inch tubing, by the way. So you go up through the flow regulator here, and it comes out, and then it goes to a back pressure regulator. So the flow regulator isn't essential. This is optional. If you don't have one, you could always just do a quick flow regulator test with a graduated cylinder or something like that. But it's really nice to have it. You have the flow rate displayed up here, as well as the RSD and as well as the turbidity. You can also even map this to your own 4-20 if you want to, which is pretty handy. So once it goes through the flow regulator, it goes to the back pressure valve right here. It's very important that these both are on the downstream side. The pressure regulator, or the flow regulator rather, to minimize any sort of turbulence that's on the sample line going in. The back pressure valve right here, this is essential to minimize the bubbles. If this isn't on the downstream side, it's not going to do anything for you. So once it goes to the back pressure regulator, then it just goes straight to drain. And that's how you set this up to minimize the bubbles going into your turb.